Hello, this is Taekyun Kim, and I'm gonna resolve the problem 10 from the exam 1. So the problem is that the electric flux density are as follows with the 4 section here. So from Z greater than 2 meter would be negative 2, and Z from 0 to 2 meters should be plus 1, and negative 2 to 0 should be negative 1, and Z smaller than 2 meter should be plus 2. So first, I'm going to draw a figure so that we can understand easier and see the figure so that we can divide up the section easier. So I'm going to divide it up as this is the z-axis, 2 meter here, 0 here, and negative 2 here. As in the question, z above 2 meter, there should be a flux density of negative 2. So it's going down like that. From 0 to 2 should be plus 1. So it's going up like that. From 0 to negative 2 should be negative 1. And from z smaller than negative 2 should be plus 2. So for this question, if we have a Gaussian surface, the integral of d dot ds over the Gaussian surface equals to the charge enclosed, so that we can calculate the charge densities using the Gaussian surface for this question. So we need to find one that is at 2, 0, and negative 2, so we can just draw the figure here, here, and here. For the Gaussian surface, we can use the equation that is a charge enclosed, which is this. D dot ds, which is flux, and the surface density integral of that will be enclosed to the charge enclosed of that section. The above integral equation states that the electric flux through a closed surface area is equal to the total charge enclosed. Then we can also apply the Gauss's law and think about that. We can say that if it's a plus charge, the electric field will be spread it out, and oppositely, if it's a negative charge, it will be electric field that is spreading out. So Gauss's electrostatic law states that a line of electric flux emanate from a positive charge and terminate on a negative charge. To show it visually, if this is a positive Q, it is emanating the charge like that. If it's a negative Q, it's terminating the charge like that. So we can apply this, and actually we can solve this problem very easily. So if we see the line z equal to 2, the charges are gathering, which we can say this is a plus charge. So that I'm going to apply the charge enclosed equation right here. There's a -2 charge and +1 charge. However, we know that this is going to be a negative charge, which is the charge that is gathering the electric field. So I can write -2 c over m squared s plus -1 c over m squared s equal to the surface density of at z equal to 2, which is simply -3 c over m squared. Same as for the z equal to 0, +1 and -1. However, since this is a positive charge, because it's emanating the electric field, we can say that both are emanating from positive. So +1 c over m squared s plus +1 c over m squared s equal to the charge density at z equal to 0, which will be just +2. Same for when z is -2, we can say it's a negative charge since it's gathering the electric field. So -1 c over m squared s plus -2 c over m squared s equal to the charge density at z equal to -2. So this will be also -3 c over m squared s. So this was the solution for exam 1 problem 10. Thank you.